Good evening and welcome. My name is Cornelia Lang, and I am a faculty member in the Department of Physics and Astronomy here at the University of Iowa, and I am delighted to be able to introduce tonight's speaker. I have served as his host for the last few days, and we've had a wonderful time engaging with students and colleagues throughout his visit. Tonight's lecture by the astrobiologist, Dr. David Grinspoon, is the last in this year's Creative Matters series. This series is sponsored by the Office of the Vice President for Research, so I would like to take a moment to thank Dan Reed, whose support of creative and scholarly work on campus plays a crucial role in many of our daily lives, as well as the lives of all who engage with our campus in various ways. The Creative Matters series brings together artists and writers and thinkers to discuss the creative process. This year, we were especially delighted that Dan's vision was to expand the series to include scientists, and several times throughout the series this year, we have included scientists, and especially tonight with our speaker. One of the most creative and inspiring thinkers in the field of astrobiology is tonight's speaker, Dr. David Grinspoon. Trained and active in planetary science research, he is broadly interested in the question of what we can learn from the atmospheres and environments of Earth-like planets, and how this can inform our search for life in the universe and also allow us to think about life on our own planet Earth. Currently, he has active research projects involving modeling data from Venus and modeling data from the atmospheres of many distant exoplanets. Astronomers now have confirmed more than 3,000 exoplanets. Many of these are similar in size and properties, potentially to Earth. These are orbiting other stars in nearby regions of our galaxy, and we are able to finally begin to characterize their environments. In addition to his scientific work, Dr. Grinspoon is an award-winning writer, having published popular books including Lonely Planets, The Natural Philosophy of Alien Life, and Venus Revealed. In 2013, he was appointed as the inaugural chair of astrobiology at the U.S. Library of Congress, where he studied the human impact on Earth systems and organized a public symposium on the longevity of human civilization. Tonight, we will hear about his optimistic and innovative view of where life on our planet has come from and the important role that humans can play on Earth in the solar system as we move into the future. So please join me in welcoming David Grinspoon.
Thank you so much. It's really been a wonderful couple days here, and I'm very happy to be here this evening to talk with all of you. I want to start by giving you a little context. As Cornelia mentioned, I am an astrobiologist, which means that I think about life elsewhere in the universe. So what am I doing writing a book about humans on Earth? Well, as mentioned in 2013, I got this rather extraordinary opportunity I applied for and was selected to be the first chair of astrobiology, which is a new position at the Library of Congress. It's a rotating position, so now since me there have been a couple other chairs doing interesting things. And by the way, this is still a new position, and they're looking for applicants. So any of you that are scholars with an interdisciplinary bent, they're interested in people from the humanities as well as scientists who have some idea of projects that are on the intersection between humanities and the arts, the sciences, and so forth. So if this sparks a thought, follow up on it and apply. It's incredible. If you haven't been to the Library of Congress, the Jefferson Building in Washington, D.C. is one of the most beautiful, maybe the most beautiful building in the United States, and working there was an honor and a pleasure. The project that I proposed that was selected, that I then worked on there, was the title, Astrobiology and the Anthropocene Era, what does that even mean? Well, the Anthropocene is the title that's now been proposed by some geologists for the time, the geological time that we have entered. It's the idea that humans have become enough of a new kind of force of change on the planet that we ought to recognize this by renaming our geological time, just as you've seen the geological time scale with these different layers that are usually represented with different colors, and the most famous movie star geological era is the Jurassic, but so we've got the Jurassic, the Triassic, and all these different eras and epochs and so forth, and the current one is supposedly the Holocene, but the idea is we have actually left the Holocene and entered a new time, the Anthropocene. It's been controversial, and that controversy has been fruitful in getting us to discuss and think about new ways of considering our influence and how we fit into the history of the planet. So my idea was to look at this concept from the lens of my field of astrobiology. We think about planetary evolution in broad strokes. I'm interested in the catastrophic changes that can befall planets and how that can lead to habitability, the ability of a planet to support life, or lead to the loss of habitability. And it was in that context that I decided it would be neat to sort of turn the telescope around and look back at Earth and see what's happening here through that lens. So that was what I proposed. I was very gratified to be accepted. I went to the library and worked for a year. It turned out to be a year and a half on this. I didn't finish the book, but I got a good start. And just recently, that has been published, and it looks like this, Earth in Human Hands. Finally, it's out. And I want to talk about that a little bit tonight and sort of lead you through some of the ideas and so forth. First, I wanted to start off with this quote from Dr. Martin Luther King Jr. because I think because I just love this quote, and I think it expresses one of the ideas that I hope I get across in this book. And here Dr. King says that if we are to have peace on Earth, and I also interpret this to mean if we are to build a sustainable civilization on our planet, then our loyalties have to transcend our differences in various ways, and we must develop a world perspective. And it is my belief, and one of the points I try to make in this book, that if we look at who we are and where we are and what we are through the lens of science, seen in a deep space and deep time context, the way we fit into our planet and what we've learned about our planet and its true global nature, that seeing ourselves in this way leads naturally to a world perspective. I want to start, if I may, by reading you a couple of snippets from the introduction of Earth in Human Hands that I feel sort of set the stage for the perspective I'm trying to bring to this topic. So I'm going to read you just a few little bits from the very beginning of the book. This is from a section called A Planetary Perspective on the Human Predicament. Gazing over the countless fluctuations and transformations in Earth's multi-billion-year history, I am struck by the unique strangeness of the present moment. We suddenly find ourselves sort of running a planet, a role we never anticipated or sought without knowing how it should be done. We're at the controls, but we're not in control. This book is my view of how we got into this situation and where that leaves us now. We are witnessing and manifesting something unprecedented and still completely unpredictable: the advent of self-aware geological change. As an astrobiologist, I study the possible evolutionary relationships between life and the planets that may host it. I see the Anthropocene as a tricky new step in the long, intricate dance between Earth and its biosphere that has been going on for 4 billion years. There are those who object to the name Anthropocene as being too self-aggrandizing, as serving a destructive, human-centered viewpoint. But this epoch is well named because it represents a recognizable turning point in geological history brought about by one species, Anthro. And our growing acknowledgement of this inflection point can be a turning point in our ability to respond to the changes we've set in motion. I believe that more than the extreme and undeniable physical changes to the planet being caused by human influence, it is this dawning self-recognition that is really fundamentally different and ultimately promising about the Anthropocene. Many species have changed the planet to the benefit or detriment of others, but there has never before been a geological force aware of its own existence. Or its own influence is actually what it says. Existence works too. And just a little bit about the planetary perspective. The planetary perspective allows us to step away from the noise of the immediate present to see ourselves from a distance in time lapse. When we do so, what we see is not just a problem facing our civilization, but an entirely new evolutionary stage in the development of life. In seeing ourselves as a geological process, we also see the planet entering a phase where cognitive processes are becoming a major agent of global change. Earth's biosphere gave birth to these thought processes, which are now in turn feeding back and reshaping its changing planetary cycles. A planet with brains? Fancy that. Not only brains, but limbs with which to manipulate and build tools. We are just beginning to come to grips with this strange new development. Like an infant staring at its hands, we are becoming aware of our powers, but have not yet gained control over them. And one last little bit here. The planetary perspective provides a kind of out-of-body experience for us, hovering in orbit and watching ourselves sleepwalk through a slow disaster of our own making. Now, can this experience help us to shake ourselves awake? For virtually all its history, Earth has evolved without us, and we have always seen ourselves as autonomous actors on a passive planetary backdrop. But now, we are beginning to see that our futures, those of humanity and of planet Earth, are tightly conjoined. If human civilization is to persist and thrive, we will need a completely new view of our planet and of ourselves, in which we acknowledge both our deep dependence and our increasing influence. We need visions of a future in which we have applied our infinite creativity to the task of living on a finite world, where we have embraced our role, become comfortable and proficient as planet changers, and learn to use our technological skills to enhance the survival prospects, not just of humanity, but of all life on Earth. My name for this vision is Terra Sapiens, or Wise Earth. A recent scientific breakthrough enriches this story: the exoplanet revolution. As we long suspected and have now confirmed, this universe is full of planets, orbiting nearly every star. It is now very close to inconceivable that we could be the only life and only technological intelligence in the universe. An interplanetary perspective on Earth's current dilemmas incites us to wonder whether parallel dramas may have unfolded on distant worlds. Do other planets also grow inventive brains that end up causing themselves problems? Do other species develop technology and build civilizations that create dangerous instabilities on their planets? How do they cope? Do planetary biospheres become self-aware? The Anthropocene leads us to a new way of looking at SETI, the search for extraterrestrial intelligence, which in turn illuminates changing notions about ourselves, how we fit into our planet, and what kind of future we dare imagine. 100 million years from now, what will our time have been? A brief climate spasm that Earth shrugged off and largely forgot, leaving a thin layer infused with bizarre plastic objects? Or the beginning of a lasting new phase when the biosphere finally woke up and adjusted its grip on the planet? So that's all from the intro, kind of setting the stage for my approach. The first part of what I wrote about, the first section of the book, is called Listening to the Planets. And I tell the story of this last about 60 years, the most recent little blip in Earth history, when we've been sending spacecraft beyond the planet and visiting the neighbors and sending information home and learning a lot about the stories of our neighboring planets, but also in the process learning a lot about ourselves and about our own planet and its story and how we fit in. There's a lot that we could not have learned about Earth without leaving it and studying other places and looking back with that enlarged perspective. It's like T.S. Eliot wrote, at the end of our explorations, we find the place where we started and see it as if for the first time. I think T.S. said it slightly more elegantly than that, but that's the gist of it. Hey, I'm an astrobiologist, not a poet. But it's that enlarged perspective that you only get from leaving and looking back. And there are many profound things we've learned about our home planet through this exercise of comparative planetology. And several of them turn out to be very useful. We discovered the problem in the ozone layer partly because we were studying the upper atmosphere of Venus and noticed some strange chemistry there that had to do with chlorine and oxygen. And then some scientists said, oh, wait a minute, what are we doing here on Earth? And that was how we first learned about the problem with the ozone layer. We've learned a ton about climate, about acid rain. The theory of nuclear winter came out of studying dust storms on Mars. These are some of the stories I tell about the discovery of the solar system, but with a focus on how we've enlarged our perspective on Earth. Even the theory of plate tectonics, our basic understanding of how Earth's geology works, only came about after we had been exploring space for a decade. And one of the profound realizations is how intimately our history, our planet's history, is related to the rest of the solar system in ways that we didn't appreciate before the space age. The Earth has been continually hit from outer space by objects, like the objects that made the craters on the moon. So why isn't Earth full of craters? Well, because Earth is continually renewing its surface. But it turns out Earth is full of craters once you know how to look for them. And so we discovered important episodes in our planet's history, like the famous asteroid that hit 65 million years ago and wiped out the dinosaurs and 80% of the other species that lived at that time. This has happened many times throughout planetary history. We couldn't really discover that aspect of our own past without looking beyond the planet. And one of the most profound insights we've gained through comparative planetology has to do with the role of life on Earth. In comparing the stories of Earth with our lifeless neighbors, Venus and Mars, we've realized how thoroughly changed, how thoroughly altered, how profoundly influenced our planet is by the presence of life. Life is not just something that sort of happened as an afterthought, not frosting on the cake. It is the cake of Earth. It permeates every system of our planet, not just in the obvious ways of transforming our atmosphere, the oxygen we breathe, and so forth, but every system of the planet, even the rocks themselves. More than 2/3 of the minerals on the surface of the Earth are byproducts of biological influence in some ways. And now we think even the properties of the interior of the planet, the way it convects and controls plate tectonics, might ultimately be controlled by biology because of the chemical influence of life that permeates even the interior of our planet. So Earth is a planet that is thoroughly altered by life. And we only realize this by being able to compare it with relatively, apparently, lifeless planets. Another thing we learned is that the very earliest environments of all these planets, and maybe of rocky planets in general, were all very similar. All three planets started out 4.5 billion years ago with, or really more like 4 billion years ago after they settled down a bit after formation, with warm oceans, geological activity, and plenty of organic matter. The conditions for life existed on all three, but if life formed on Venus and Mars, we don't know yet if it did, but it only stuck apparently, on one planet. And although we know now that all three of those planets started out with very similar environments, we learned that shortly after they were born, each of the three suffered some kind of a catastrophic change in conditions. In the case of Venus, it was what we call the runaway greenhouse, and Venus became a desiccated, self-cleaning oven where life like ours could not live. In the case of Mars, continuing the kitchen analogies, Mars became a dried-out freezer, frozen desert, not a frozen dessert, but a frozen desert where it seems like, at least on the surface, nothing can live. And Earth went through its own kind of catastrophic transition. Namely, Earth came to life and was soon taken over by biological systems which altered every aspect of the planet. And I describe it in this way as sort of a setup, because my point here is that Earth early on in its history went through this profound branching point that the other planets didn't undergo, which was coming to life. And I suggest that this transition that Earth is going through now, as a result of human influence, is potentially as significant a branching point, that we may be not just at another interesting fluctuation caused by yet another planet-changing species, but at some kind of a profound branching point in planetary evolution with a choice of directions that we could go. The next part of the book, I discuss human influence. I sum up human influence from the Earth's point of view. And the title of this section is Monkey with the World. And what I want to do now, if I may, is read you a little bit from just the very beginning of that section. This is from a section called Something New, from the beginning of Monkey with the World. And of course, it begins with a quote from the Grateful Dead. Who can stop what must arrive now? Something new is waiting to be born. Have you noticed that something strange is happening to Earth? Take a good long look at this world, a dazzling blue orb festooned with spiraling clouds, spinning through star-flecked darkness. Dayside glinting in slowly brightening sun, winter white pulsing between north and south as Earth ambles through its orbit. Now, imagine you are a very patient alien regarding Earth over the eons. If you've been watching carefully for, say, the last several billion years, you've seen a lot happen. The brown continents drifting around the oceanic globe, coalescing and breaking apart, animated pieces in a morphing spherical puzzle. The polar caps growing and shrinking, advancing and retreating as climate rocks between ice age and hothouse. Throughout all these changes, the night side remains a nearly unbroken black. And the dayside continents are the stark, dull gray of bare rock. After 4 billion lonely years, a green fringe first edges over the land, and the night starts to sparkle with occasional forest fires. Still, for the longest time, the unlit hemisphere remains as black as the starry space surrounding it. The dark interrupted only by these fleeting fires and by occasional flash of lightning or splash of aurora. Until, very recently, in the last few hundred years, just a twitch in the life of the planet. Whoa, what is this? Something new. Suddenly, the planet lights up in a peculiar spidering pattern that seems to reflect an organic process, but something else as well. Something cognitive. Starting in a few isolated river valleys and coastal areas, glowing points appear, abruptly dotting the night, then stitching together and spreading along widening and brightening webs, hugging the shores, and eventually growing in loose nodal patterns across the interiors of the lands. On the day side, a mesh of dark lines becomes visible, winding between the locations of those night lights, each swiftly surrounded by a growing verdant grid of novel angular geometry. Soon, regular movements of small wave-generating objects start crossing the oceans, and bright linear clouds start streaking the skies. At the same time, a host of other accelerating changes are observable in the atmosphere, the land, the oceans, and the ice. Finally, just 60 years ago, a blink and you missed it interval in this fast-forward view, began the curious anti-accretion, with small bits of Earth stuff jumping back into space. Little insect-like constructions of refined metal, bristling with sensors, thrusters, and radio antennae, started leaping back off the planet, sailing first to the nearest worlds and then to those farther afield, sending pictures and other information home to their inquisitive builders, signaling the arrival on Earth of curiosity and gravity-defying technology. Yes, after billions of years of geology as usual, something new and strange is definitely happening here. What is the meaning of these changes? And then I tell you. This is my intro to pose the question of all the intense and dramatic fluctuations and catastrophes and crises that Earth and its life have been through over the eons. What is different about what's happening now from the planet's point of view? After all, if you study planetary history, one thing you learn is that we are not the first species to come along and really wreck the planet for other life. In fact, these little guys, the cyanobacteria, did it 2.5 billion years ago. They look innocent enough, don't they? But these cyanobacteria, what they did, they discovered a new energy source, and they exploited it to the max, spread around the planet, poisoned the atmosphere, and led to the most dramatic climate crisis this planet has ever experienced. The energy source they discovered was solar energy. These guys perfected photosynthesis using photons of sunlight to break apart molecules of carbon dioxide and water, using the carbon to make organic stuff, food, bodies, fuel, and spitting out the useless waste gas, which was O2, oxygen. And that's what poisoned the planet. Oxygen is poisonous for organic life. That is, organic life that has not, as we have, evolved to harness the energy that comes out of oxygen. Reacts very powerfully with organic matter, and reactions that are exothermic, release energy. So before respiration evolved, which is how we power ourselves, when oxygen appeared, it killed off all life that couldn't sort of hide from it in what we call anoxic environments, hiding from the air somewhere. And it caused a climate crash, because at that time we think the Earth was being warmed by a methane greenhouse, and oxygen destroys methane. This plunged the Earth into a global glaciation that we call the Paleoproterozoic snowball Earth episode, where the planet was completely covered with ice to the point where it might have come very close to completely extinguishing life on Earth. This was a catastrophe. What happened later, of course, is that oxygen, we don't think of oxygen as a terrible poison, because those same powerful chemical reactions that were threatening when it first appeared, life evolved to harness. That's respiration, and in each cell of your body there are little power plants that use these powerful reactions of oxygen and organics in a controlled way to store up energy, and that's how we live. But before we evolved that capacity, this was a very dangerous development for the biosphere. So we hear this story, though, and what we don't generally think is those irresponsible bacteria, those cyanobacteria, how could they? What were they thinking? You know, we don't think that because they're bacteria, and they don't think. But yet we see ourselves behaving in a way that seems analogous, and those of us that have some awareness of this rightfully feel a great deal of concern and responsibility about this. So what is the difference? What have we got that the cyanobacteria didn't have? That's one way of sort of asking who we are, what is the role that we're playing on this planet. And in an effort to parse that, I've thought about all the different kinds of catastrophes that can happen, that have happened and can happen on planets, and I've decided that they sort of fit into 4 categories, 4 kinds of planetary change, categorized with respect to the role of life. So what I call planetary changes of the first kind are random catastrophes. An asteroid comes and hits, or there's a massive outpouring of volcanic lava because of some slight change in the dynamics in the interior of the Earth, and a lot of species get killed off. There's a mass extinction just because of the kinds of random changes that occur on planets, presumably throughout the universe. This is when bad things happen to good planets. And the way I distinguish random catastrophes in this taxonomy is that life has nothing to do with it. No implication. Life is just an innocent bystander. Not so with what I call planetary changes of the second kind, biological catastrophes. This is when the evolution of life itself leads to some profound change in the planet which is harmful or fatal for many other species and causes extinction events. I already gave the example of the cyanobacteria and what happened when photosynthesis came along, which is why I represent this with a green leaf. That's probably the best example, although there are several other examples in planetary history when a species was just so successful at doing what it did, what species do, which is multiply and change their environments, that it led to planetary transformations which were dangerous and incompatible with survival of other species. So that's planetary changes of the second kind. What I call planetary changes of the third kind are inadvertent catastrophes. This is where the cognitive processes enter into the story. And this is when a species, a very clever species, develops the ability to manipulate its environment using technology and some kind of social cooperation, and is so successful at this that they manage to perpetuate, propagate themselves around the planet, and without having any idea they are doing so at first, start to cause global changes which are incompatible with the survival of other life. And I symbolize this with traffic because here you can see that these individual cars are driven by creatures that have agency and are quite good at controlling the emotions of those cars, and they can steer around obstacles or hit the brakes if they need to. And yet you can also look at the system as a whole and ask, who is driving the global transportation system? And the answer is kind of nobody. And yet we're participating in it. So this is what I mean by planetary changes of the third kind. Cognitively, you can look at it as the situation you're confronted with when your influence exceeds your level or scale of awareness. It's cognitively like a child who has not yet developed situational awareness, so might crash into things and inadvertently knock things over because he or she has not yet fully become aware of their scope of influence, or the bull in the china shop, or you can look at this through systems analysis as well. But this is what I mean by the Anthropocene dilemma, that we have influence that exceeds our scale of awareness. As individuals, we have some awareness, sometimes a great deal of awareness of our global influence. But as a collective global entity, we don't have the ability to fold that into our global behavior. And that is inherently unstable when your influence exceeds your scale of awareness. So some examples of these changes of the third kind. Obviously, the most pressing is the fact that we through our use of fossil fuels, have been changing the atmosphere in such a way that we are causing dangerous climate changes and threatening worse dangerous climate change. I'm not going to dwell on this because I think you're all familiar with the fact that carbon dioxide is rising. This is the famous Keeling curve. In my lifetime, carbon dioxide has risen by about 30%. That's not a minor change. And this is a wonderful animation from the California Academy of Sciences that shows the places where the most CO2 is being emitted, which are the industrialized urban areas, and the places, if you watch this carefully, you can even see the places where CO2 is being taken up by the Earth, which tend to be the forested continents. And we're all familiar with many of the frightening consequences of this, such as the decrease in the Arctic sea ice and so forth. So this is inadvertent change. When we started burning fossil fuels, we didn't say, hey, let's change the climate. We said, hey, this is a neat source of energy. And it was, but we didn't foresee what was going to happen from this. Another example of one of these inadvertent changes is, I've already mentioned, the ozone hole, which was partially discovered because we were exploring the planet Venus. Well, here you can see we learned about it in the 1970s, and the hole started getting deeper and deeper throughout the 80s and 90s, and then it kind of stabilizes in around the end of the 20th century, and now it's actually starting to go away. What happened here was it was completely an unintended consequence of these new chemicals that had been introduced to be better refrigerants. They were safe, they were non-toxic, they were environmentally friendly, and they were. Down here where we live in the troposphere, these CFCs, they don't react with anything. They were much safer and much more environmentally friendly than the refrigerants that they replaced, which were nasty things like ammonia. But nobody thought through all the consequences of introducing them into the environment. We never can. So there was a serious unintended consequence when they started diffusing up into the stratosphere, where they are no longer safe and non-toxic and environmentally friendly because they get attacked by ultraviolet light, and the C's, one of the C's in CFCs is chlorine, gets split off, and when you have naked chlorine molecules, they eagerly attack oxygen compounds like ozone in a catalytic way, which means a little bit of chlorine can destroy a lot of ozone. And fortunately, we discovered this was happening on time, again, partly because of pure curiosity-driven research to understand other planets. And what happened next was interesting. There was a global discussion about this, actually kind of a global debate at first. There was a lot of resistance. Some scientists hired by industry said it was a hoax and deliberately caused confusion and delay. It was not universally accepted at first, but then when this ozone hole started to deepen, it spooked a lot of people. It even spooked the people in the DuPont Corporation that were the major manufacturers of CFCs. And ultimately, the truth won out in this case. Global agreements were made, most notably the Montreal Protocol, which was a global agreement to phase out these CFCs. And it worked. This is a success story. The hole in the ozone layer is now on track to being fixed, and there's every reason to believe that it will in another 50 years. It takes 50 years to heal itself, even if we stopped completely squirting the dangerous stuff up into the stratosphere. We are on track to fixing this, so it's a success story. To me, I'm expounding upon this because not only is it an example of inadvertent change, planetary changes of the third kind, but I also use it to introduce the fourth kind of planetary change, which are intentional planetary changes. The ozone hole is an example that we are able to respond to global threats in a different way. We have it within us to have a reasoned global response to a global threat that meets the threat, we change our behavior in a way that preserves in this case, one of the crucial life support systems of our planet. This doesn't mean that it's going to always be easy, that we can always do it. There are ways in which some of our current problems are inherently more difficult than solving the ozone problem, but I do think it serves as a very important proof of concept, an existence proof of this kind of solution. And by the way, it wasn't that the DuPont Corporation and the other corporations making these CFCs suddenly abandoned the profit motive and said, oh, we just care more about global health. We give up. We don't need money. What they did was they saw profit potential in manufacturing the replacement chemicals that would be needed for new refrigerants to replace the CFCs. So they were able to pursue their profit motive, but guided by this set of global agreements that within which they could pursue that in a way that was not injurious to the health of the planet. So other examples of potential current and potential future planetary changes of the fourth kind. Well, most crucially, we just have to change the way we generate energy and have global energy systems that do not destroy the natural systems upon which we depend. The good news is this is definitely happening. Solar and wind are getting cheaper. Coal is on its way out no matter what anybody says. It's certainly true that 100 years from now we won't be using fossil fuels any more than today we're using whale oil, and it will seem just as regrettable, and just as we kind of wish we had stopped using whale oil a little earlier and done a little less damage, we'll regard fossil fuels the same way. The question is, how much damage are we going to do before we make that transition? The transition is inevitable. It's what's scary and concerning is the rate at which we're making that transition, and we need to hurry up. But it is happening. When we think of this different mode of intentionally interacting with the biosphere, it's interesting to think farther into the future, to a time when we get past our fossil fuel addiction, which we will. What other, if we can imagine then taking a more constructive role in our interactions with the planet, what other kinds of dangers to the planet, to the biosphere, to ourselves and other species can we picture forestalling? And when we start thinking on a longer time scale, and part of my message is that we need to think on a longer time scale, that now that we're waking up to the reality that we are a geological presence on the planet, we have to think like a geological force and realize that we are setting in motion and we are part of processes that act not just on the scale of our own lifetime, but on the scale of many generations and even thousands and tens of thousands of years. We have to think ahead. And when we do so, we realize there are other threats, potential survival threats to the planet that we can become aware of and we can do something about. For instance, I mentioned the dinosaurs getting nailed by a giant asteroid. There are a lot of other objects out there that could do the same thing. This is actual data showing, you see the orbits of Mercury, Venus, Earth, Mars, and all of these little insect-like things, each one of these is a known object out there on an Earth-crossing orbit. Now, don't worry, this is sped up by a lot. This is not something you have to lose sleep over tonight. If you want, I can tell you things that maybe you should lose sleep over, but it's not this. You probably don't need my help right now. But the point is, on a long enough time scale, it is not just possible, but inevitable that Earth will be hit again. But we don't have to let that happen. We can see these coming, and we know it's an engineering problem, and we know how to solve it. So in the long run, I think it may well be that we can save many more species than we're currently threatening, because we can prevent the next mass extinction and the one after that. Once we get over our current vandalism, which we have to, not just ethically for other species, but for our own survival, then we're left with other ethical obligations on a longer time scale, and this is one of them. You can also think about climate on a longer time scale than we're used to thinking about. We have this illusion that left to its own devices, the planet will be fine for all life, that Earth is a paradise, that if humans just left it alone, it would be lovely for all time. That is an illusion because we've come along at an unusual time in Earth history. Our entire civilization, such as it is, has sprung up in a roughly 10,000 year period of relatively warm and stable climate. That is unusual in planetary history and will not last left to its own devices. Now we're talking about thinking 50,000 years ahead, not something we're used to doing. But, you know, so our civilization, such as it is, has been here for roughly 10,000 years. Think, again, that same time scale in the future and a few more of those time scales, and then we run into the inevitability of another ice age. Well, you don't want to try to live through one of those. It would be much more profound a threat than the climate changes we're facing and causing now. During the last ice age, North America was largely under a mile of ice, and our civilization couldn't survive that, and a lot of other species couldn't as well. But given that much time to work the problem, and given now that we've learned how even accidentally we can cause climate change, it probably wouldn't be that hard for us to put our finger on the scale a little bit and prevent this. I think it is a preventable problem. It's not something we have to worry about right now, but again, it's part of this exercise of thinking on longer time scales and reconsidering our role on the planet. The last thing that I discuss in the book is the possibility of other civilizations in the universe. I would say the inevitability. And I do that as a way of, for the purposes of this book, of shedding a different kind of light on our far future. The theory of SETI, the search for extraterrestrial intelligence, is something that scientists have been thinking about and writing about really since the late 1950s. And when you do the math of SETI, one thing you realize is that the crucial factor when you're trying to answer this question of how many other civilizations might there be in the universe, the crucial unknown factor is what we call L, for longevity of civilizations. It all hinges on that. If it's impossible for a civilization to live for a long time with powerful technology, say they typically last only 1,000 years or less, then there's going to be nobody to talk to. Because while you can picture the galaxy with these little lights blinking on occasionally in different places of brief flashes of awareness and civilization, the chances of two of them being close enough to one another, being on, if you will, at the same time, so that they could possibly be aware of each other, let alone find a way to communicate, is almost zero. If, however, civilizations, some fraction of civilizations can last for a much longer time period, say tens of thousands or hundreds of thousands or even millions of years, then it really changes the equation, and the likelihood that two of them will be existing at the same time near enough to one another to find each other and possibly even communicate at the speed of light, it becomes very likely. So SETI theorists have been thinking about the possible longevity of civilizations for a long time. Now, confronted with all of these existential threats of our own devising in what we're realizing is this new geological epoch of the Anthropocene, I think we're realizing the central question of SETI is the same as the central question facing us, which is it possible for a civilization with powerful, world-changing technology to develop a long-term, healthy, sustainable relationship with the planetary biosphere? So by thinking about this in terms of other civilizations, it's just a way of abstracting the problem that we are confronting now. There's a transition that may be happening on our planet that I believe probably has happened elsewhere. And it also gives a sort of hopeful aspect to the SETI search, because we're not just listening for evidence of something out there. In a way, we're searching for survivors of this transition that we are now confronted with. If it can be done, then maybe there are others out there. If there aren't any others out there, maybe it means it can't be done, and that's a bit of a dismal possibility. So when we think of the far future of Earth, again, let's go back to the geological time here for a second. The Anthropocene has been proposed as a new epoch here after the Holocene, which is what we're supposedly in or have been in since the last ice age. And the thing about epochs over here on the right side of the geological time scale is they're rather common. They last 10 million, 12 million, a few million years. They come and go. And these are basically fluctuations in different kinds of conditions. They lead to, they're often marked by extinctions or mass extinctions, these boundaries. But from the perspective of the Earth, these are not major transitions. They're just sort of fluctuations. But if you go to the left side, you know, so we've got epochs and we bunch things into bigger and bigger units of time, periods, eras. And over on the left side, we've got the eons. There have only been 4 eons in Earth history, and these are characterized by major transitions in the very nature of the planet. Earth was a profoundly different planet during each of these eons, and each of these boundaries, these transitions, are characterized by a transformation in the relationship between life and the planet. This is the origin of the Earth, and the first of these was called the Hadean, and it was when Earth was like hell, Hades, and it was just all asteroid impacts and steam and volcanoes, and nothing could live, or believe me, you wouldn't have wanted to try. But this boundary, the Archean, about 4 billion years ago, this is basically the origin of life, the existence of the most simple life. And then here, the Proterozoic, 2.5 billion years ago, this is pretty much when life took over the planet chemically. This is that great oxygen catastrophe that I mentioned. And then here, about 600 million years ago, this is the beginning of the Phanerozoic. This is when life became complex, the origin of plants and animals, multicellular, complex life. Now, supposedly we're in the Phanerozoic now, but I've proposed the possibility that what we're really experiencing is not just a beginning of a new epoch, but possibly the beginning of an eon boundary, a new eon, the beginning of the 5th eon in Earth history. Now, why would I say that? I mentioned that each of these is characterized by a fundamentally different relationship between life and the planetary environment. And it's my thought that if cognitive life, self-aware life, can become a long-term integrated part of the Earth system, then maybe this is as profound a change as any of these others and deserves to be called a new eon. And I hopefully call it the Sapiezoic, the time of wise life. And I know that seems aspirational. It is aspirational, but it can only be an eon if it persists for an unbelievably long period of time, which would require that it be the era of wise life. So it's aspirational, but I think it's accurate in that sense. I want to close with some thoughts about pessimism and optimism. Our species has been through a lot. We've been profoundly shaped by climate changes before. When you learn about the deep history of the human species, you realize that most of the innovations that led us to become modern humans were caused by responses to climate change. The origin of upright walking, of larger brain sizes, the use of language and various kinds of tool use, the domestication of fire. You find that there's a correlation between, there have been the long periods of climate stasis and then periods of climate havoc. And most of these major innovations, evolutionary innovations, came about as responses to challenges, existential challenges that had to do with climate chaos. This is a site in Africa called Pinnacle Point, where some scientists think this is where the origin of modern humans happened. We're not sure, but Homo sapiens sapiens may have been born right here. What happened was there was an ice age over most of Africa at this time, and we couldn't be hunter-gatherers in the way we had been because the game died out. There was no range for the game. It was largely covered by ice. And the human species may have dwindled down, or our pre-human ancestors, to a very tiny number. We almost went extinct then. There's a genetic bottleneck about 190,000 years ago. We might have been down to less than 1,000 individuals, which then propagated again the entire human race, which is, by the way, why there's almost no genetic diversity amongst the human species. We're remarkably genetically uniform for a large mammal because we came out of this bottleneck. How did we survive? Well, we couldn't hunt for food the way we had, and there's a lot of evidence that the humans here at Pinnacle Point, or our pre-human ancestors who may have been the first humans, found new ways to innovate with both material and social technology. They developed what we call complex recipe long chain technology. I might have said that wrong. It's long chain complex recipe technology. The idea is that you are doing things like heat treating rocks to change their property that are not obvious how to do it. From the starting materials don't obviously suggest the ending materials. It's a complex recipe, and it has to be taught to succeeding generations. So not only does it require technical innovation, but it requires social innovation, new levels of language and cooperation. This is also one of the places where we first find ochre and other pigments, suggesting body adornment and art, and a lot of the other things that made us human originated here or places like this. And what the people at Pinnacle Point did was they learned how to live from the sea largely, and they invented new tools that allowed them to gather shellfish and hunt for food in the sea and so forth. And so it was in response to the threat of climate change that we became more fully human. I find this very encouraging because it means that in some very real way we have evolved as climate change survival machines. And we've survived by enlarging our ability to cooperate and innovate. And in a certain sense, that's what we need to do again. We've reinvented ourselves before in response to existential threat, reinvented our relationship with the natural world. In a certain sense, we need to do that again, maybe even now becoming fully human by learning to enlarge our circle of cooperation to a global scale. People will sometimes say this is impossible, it's human nature to not be able to cooperate on that scale, and that we're doomed because you can look at our recent behavior and extrapolate it into the future. But I think when people say that, they're suffering from a lack of imagination. As Ursula Le Guin once said, well, people think our current system of capitalism is inevitable. They once said that about the divine right of kings. And if you imagine if you had somehow been able to talk to one of our hunter-gatherer relatives 100,000 years ago and tried to describe to them a modern city, it would be very, very difficult. You wouldn't really be able to describe it in a way that it would make any sense to them. Maybe that's just as hard, would have been just as hard for them to imagine as it is for us to imagine the global civilization, the sustainable global civilization that we might have a few thousand years from now. It's always hard for us to imagine reinvention, but reinvention is what we've done time and again. And by the way, the first modern cities were really horrible places to live. We still have problems, but they're a lot better. When we first gathered in that kind of density, we used to just throw our human waste into the streets. Our cities were public health nightmares. And then we invented this wonderful technology, sewer systems, which we're usually unaware of because when they function well, they run beneath the streets and we are unaware of them. We're supposed to be. But that allowed us to live with the kind of density we live in now. Well, in a certain sense, our challenge now is to invent the sewer systems of the 21st and 22nd century. Now we're throwing our waste into the atmosphere, and we need to invent our way out of that. And I think there will come a time when we look back and at our current behavior with regards to internal combustion engines and such and think, that was really pretty dumb and it wasn't really that hard to solve. I want to just say something quickly about the metaphors we use to describe ourselves. We often talk about the human presence on Earth in these metaphors of crime and disease. We're a cancer, we're a virus, we're criminals, we're raping the rainforest, and so forth. And you know, there's a truth to that, but I think it's dangerous to limit ourselves to those kinds of metaphors, because a cancer does not have a conversation about being a cancer and say, you know, maybe we shouldn't keep multiplying like this. It might not be good for the host organism, you know. We're at least having those conversations. So I think that it's worth coming up with different metaphors that also encompass this other aspect of ourselves and the possibility of maturity and growth and change. So there's one that I like is the metaphor of childhood or adolescence, that in a certain sense we are do find ourselves in this situation that we are not fully prepared for on this planet, and the need to kind of grow up. And there's the metaphor of the unschooled driver, where sort of waking up to find ourselves behind the wheel of this big rig and going, oh, I'm driving this thing, but I don't know how to drive. Well, I better learn in a hurry, because everything and everybody I love is in the back of this thing, and I don't want to go careening off the road. There are some other metaphors for our situation that I think are also have some truth, that don't lock us into, that don't prescribe our past behavior. So let me end then with one more short reading about optimism. There's a section in here in the last chapter. The last chapter is called Embracing the Human Planet, and there's a section where I talk about the danger of some of the apocalyptic thinking that's going on now. I talk about different kinds of pessimism, and how some of it is useful and motivating, and some of it is kind of enervating and can lead to nihilism and fatalism, and how that's dangerous. So that section is called the power of negative thinking. And then I end with a taxonomy of optimism, which I want to read to you now. This is the last thing I'm going to do. I'm going to read you almost the end of the book. I'm not going to read the last 2 paragraphs. Yeah, don't want to give away the ending. Right now, the subject of the future is rife with anxiety. Visions of apocalypse dance in our heads. The topic of the Anthropocene is often associated with doom and gloom, with an "is the earth fucked" mentality. This is understandable, but it's not the whole story. Let's not dwell on these prophecies to the point where they become self-fulfilling. I propose that, on the contrary, the true Anthropocene is something that should be welcomed. Though it is yet only in its infancy, it can be glimpsed. Don't fear it, learn to shape it. It is the awareness of ourselves as geological change agents that, once propagated and integrated, will provide us with the capacity to avoid doom and take our future into our own hands. Understandably, we are uncomfortable with our role as reluctant planetary engineers. Discomfort sometimes manifests as self-loathing and denial. But this is our task, and we can't afford to wallow. It's time to human up. We have to stand and face it, get up on our big bipedal frames and look in the mirror. Wake up to find out that we are the eyes of the world. Earlier in this chapter, I described flavors of pessimism. There are flavors of optimism, too. There's cosmic optimism, stemming from a belief that the universe in its vastness bends towards life and intelligence, and that what happens here doesn't really matter anyways, because there's plenty more where we come from. There's data-driven and historically based optimism, which focuses on positive indicators, of which there are many. Poverty, malnutrition, and infant mortality are in retreat globally. Levels of education are on the rise. Communication continues to become cheaper and easier. Population is plausibly heading towards stability. Solar and wind energy are getting cheaper and will continue to do so. These are all trends toward human freedom and environmental sustainability. There's pragmatic optimism. We really don't know what is going to happen, so why not spread hope and encourage engagement? Exponential technological innovation is transforming our world in surprising and accelerating ways. Possibilities that until recently seemed magical are now imminent, rendering the future frightening and exhilarating, but above all, unpredictable. Where there is uncertainty, there is also hope and choice and room for faith in ourselves. I believe we're just getting started on this planet. Nobody knows the odds of our being able to navigate the evolutionary obstacles before us, but there is a real hope, and it is this: that our evolving technological capacities can allow us to maximize our innate social prowess, equipping us to meet the novel threats we have accidentally created, and to become something new in the process. We have done this before.
So we do have time for questions, and David, I'll let you call on people.
Sure, yeah, sir.
What would you say to someone who maintains that the best hope is a pandemic?
That the best?
Our best hope is a pandemic.
Well, so the question is, what would I say to someone who maintained that the best hope is a good pandemic? You know, there are...
Huge reduction in our numbers.
Yeah, absolutely. I mean, there are, you know, so my view in general is to surmise that we have become a planet-shaping force, and we cannot turn back from that, and our best option, our only option, is to learn how to be a constructive and learn how to do it well and become a good planet-shaping force. There is, of course, another option, which is that we somehow drastically reduce our numbers on the planet and go back to being just another animal. I think that would work for a while. I think we're sort of innately civilization builders. I don't know if we would sort of be able to keep ourselves down for that long. It's true that something like a pandemic could potentially, may potentially drastically lower our numbers. That would solve in a certain way the climate problem and a lot of these problems, but it's not like that's something we can wish for. You know, unless I don't know how to respond to that other than to just say, no, that's not a good idea, because I love humanity, and I don't think that, you know, people who are mass murderers and genocidal maniacs have a good idea, and that falls into that category for me. So yes, it would solve the problem in a certain sense. I mean, let's face it, a nuclear war would solve the problem, but that is not something that we, you know.
Every environmental problem is secondary to overpopulation.
That's right. But yeah, no, every environmental problem is secondary to overpopulation. That's true. But the good news, there's good news on that front, which is that all reasonable population projections show it peaking later this century and then starting to come down for the right reasons, not because of an increase in the death rate, but because of a decrease in the birth rate. And the reason why that is happening, and that's already happened, we've already passed peak birth rate. It's going to take a while to pass peak human because of life expectancy, which is on the rise, which is a good thing. But the reason why birth rate is going down is because poverty is going down, and it is globally over the long run. And in particular, choices for women in poor countries are becoming better. And if there's one thing that you want to do, if you're concerned about population, the biggest lever we have is to support education of girls in poor countries. It's known that this is true, and that is happening, and birth rates are coming down because of choice. And so it is scary, the fact that later on this century we may have a world of 10, possibly even 11 billion people. But it's not going to go up to 12 and 15. All the projections show it's going to curve over and start to decline without a pandemic. An interesting question on the long run is what, and I don't know anybody who's told me that they have a convincing answer to this, is what is a good human population for the Earth? Is it 1 billion? Is it 100 million? It's an interesting, that's not our problem right now, is to figure that that out. Our problem is to stop our more immediate trends. But in the long run, it would be an interesting thing to see what choice becomes made about that. And I've heard a lot of that. That's a tangent I won't go into now, but that's an interesting discussion. But I don't think we're going to need a pandemic to decrease our population. And I agree with you, the population is sort of the uber problem behind all other environmental problems. Yes?
So I like your taxonomy of change, but the third category is potentially a kind of dangerous one because it's potentially a catch-all, and it's kind of one of those places where people can find themselves and be denialists. And so even though some proportion of the population understands that what they're doing is absolutely in the fourth category, there's an ability to deny that this is all unintentional effects. We don't really know what's going on, kind of thing. We see that right now, currently in our way of thinking about our certainly national policy. So one of the issues I have with that is in that taxonomy is how do we move people from being comfortable in that third category and saying, yeah, whatever, versus being aware that we're actually in the fourth category?
Well, I mean, the whole point, that's a good question. I mean, the whole point of the third category is that you shouldn't be comfortable in it because it's unstable. If you're having effects that you're unaware of, and whether you are as an individual or not, we can also think of the sort of cognitive level of global humanity, and at that cognitive level, we're sort of like that child who has not learned how to not soil itself, and we just, it's not that hard if you look at it that cognitively. We just have to get at the next level where we're sort of toilet trained as a species. So for me, the whole point of kind of pointing it out this way is to try to further the conversation and spark a realization that whatever you believe about economics or policy or whatever, it is clearly not a good idea to be behaving in a way where you're going to be soiling your own crib. I guess maybe what you're asking is, how do we convince people who think they're who don't accept that they're in that third category? I guess part of my appeal is that we think, I think we're very entrenched in our thinking. And I've, living in Washington, D.C. now, I've met some, and especially when I was working at the Library of Congress, I've met some policymakers who are what you and I would call denialists. I've decided I might stop using that word, even though it's accurate, by the way, because it turns off conversation. You're basically saying you, with your belief, are like a Holocaust denier. And in some ways, you are, because denying the facts of science is just as bad as denying the facts of history, and that's why it's a powerful thing to say. But it does stop conversation, and so I'm on the fence about whether it's a good thing to say, even though it's accurate. But at any rate, I think that we're at this point where we need to find other ways to enter that conversation because we've become so entrenched. And that's why I've actually had this experience of going into a congressperson's office and saying, I know that this guy's a climate denier. Between you and me, I know that's what he is. But I'm not just going to come in and say, hey, Congressman so-and-so, you're wrong about climate, and I'm a scientist and I'm going to tell you, because I know he's not going to listen. So I try to find a different thing to talk about, and I say, and I happen to know this guy's really into NASA and exploring the planet, so I start with talking about Venus and the climate of that planet. And by the way, here's how we know about that, and sort of get into it sideways. So part of what I'm trying to do is find ways to reframe the conversation to be able to have the conversation with people that we're sort of stuck by hitting it head on. Yes?
There are a group of people that I think have the creativity and the willpower to actually carry through and are ready to colonize Mars. So what would you say to them in terms of critical mass of what's needed for them to go and deliberately change the geology and create biology?
So, yeah. The question was, and tell me if I get it right. It's basically about the possibility of colonizing Mars, and the people that are sort of ready, willing, and able to do this, what would I say to them about what is actually required to do that? Is that?
Yeah, and so it minimize their inadvertent changes, right? Like, how are they going to decide what are good changes for the long term?
Right. Well, no, I mean, it's a great question because, I mean, personally, I'm intrigued by the idea that someday we might go and live on Mars, but I'm not an advocate that we should start going and trying to terraform and change Mars right now, because we don't know what we're doing. We don't know what we're doing on Earth. We don't know what we're doing on Mars. But the thought experiment of how we would terraform Mars is terribly useful, because it gets us to think about how would we intentionally interact with the planetary biosphere if we decided it was a good idea, as opposed to unintentionally stumbling into causing change on a planetary biosphere as we've been doing now. I think in the long run, there may be a human destiny on Mars. Not as an escapist fantasy, which is something that I do sometimes worry that it is for some people, but as a way to help expand and preserve the domain of life. But we've got a lot of homework to do first. First, we have to discover if there is any life on Mars. And if there is, then that really changes the ethical equation about what we should do there. Second, we have to learn a lot more about how planets work. That includes Mars and Earth. And we have to think long and hard about our interactions with the biosphere. I think it's going to be much harder for people to go live on Mars than we think. Remember Biosphere 2. We say, oh, it's not going to be that hard. We'll create an enclosed simulation of the entire biosphere. We'll go in and live there for a year. Well, it didn't work because we learned that we were oversimplifying the problem. We've still got a lot to learn about ourselves and the way we interact with our environment. We've just learned about the microbiome, that most of your cells aren't even you, or they are you, but you're not what we thought you were, that you're a community of other organisms, and so the way we interact with our planetary biosphere and our surroundings is much more complex, I think, than we still realize. And that when we do go and try to live on Mars in a self-sustaining way, and let's not call it colonization, that word is tainted by history. Let's say when we go settle Mars, when we try it, I think it will fail at first. And I think in that failure, we'll learn some important things about the way we relate to our planetary biosphere. So I support the thought experiment. I think it will be a neat thing to try someday, but I think we have a lot more to learn about ourselves and about how planets work and about how we interact with planets before we'll really be able to do that. Time for one more. Who's got a killer last question? Well, I see two. Can I do two killer last questions? Oh, what? No? Just one? No. Okay. How about you and then you? Okay.
Okay, so I'm just wondering, does it freak you out that you're studying things that you weren't alive for, or that you're studying things that will happen in the future that you will not be alive for, so over millions of years? It's kind of freaking me out.
That's a great question. Did everybody hear the question? Yeah. I would say yes, it freaks me out, but in sort of a good way. It's crazy to think about things that happened long before we were alive and imagine things that will happen long after we're gone. But that's what we do when we study history. Right? And so geology is just an extension of it. When we study the Civil War, or when we study, World War I, or when we study the original migrations of humans from the African continent to people, the rest of the planet, those are things that happened long before we were here. So it's just an extension of that when we just study geological history and think about things that happened millions of years and billions of years before us. So once you get used to that, it's just stretching it further. And thinking about the future, it's a little strange to think about things that will happen long after we're here. But there's another way to look at it. There's a way in which I find it kind of comforting, because the more we study Earth and biological evolution and geological evolution, we realize that we are embedded in systems and processes that are much bigger than ourselves and much more long-lived than ourselves. So it makes me feel, I mean, personally, I'm not a religious person in that I don't believe in that there's some afterlife in a literal sense, and I don't mean to put down anybody that does believe in that, but it's not my personal belief. But I do find some sort of spiritual value in thinking of myself as part of this evolutionary process and part of this project of creating a sustainable civilization that I know I won't live to see, but it allows me to think of the role that I'm playing. I'm at least, laying a stone in that foundation, hopefully, even if it's just a little tiny chipped one that will need to be replaced later, but I'm doing something that is maybe part of some edifice that will go on and exist. So just like, I think of it as, I think of the people that built cathedrals, and these cathedrals, the great cathedrals of Europe that took centuries to build. And you think, well, what were the people thinking that laid those first stones and knew that they would never be around? And they felt motivated, they felt part of something, and I think that helped give their life meaning. And so I see, just being part of the scientific community where, my students will go on and do things and their students will go on and do things after I'm here. And part of this human project of trying to reimagine our future and hopefully ensure a safe and sustainable future, that to me feels like a meaningful thing to do. So, it does freak me out, but there's a way in which it also comforts me. Does that make sense? And then there's one more question over here.
What are your thoughts on the message of scientists and how it can get distorted through social media, or they get the correct message but they get a portion of it and it's cherry picked and you don't get the other portion that would be the natural consequence, but people are uncomfortable with that?
Yeah.
How that gets propagated into Einstein or something.
Yeah, well, I think, we are at a strange time in our evolution where we have these new tools which connect us in new ways, which has tremendous positive value as far as the necessary transition of perceiving ourselves in some way as a global entity. The fact that I have this little gizmo in my pocket that I can communicate directly with people anywhere around the world. I have friends, in Africa and South America and Australia and Japan and all these places, and I can just, if I hear about something on the news, I can send them a little message and say, hey, what's up? What's going on there? And this connectivity is an amazing thing. But we're also experiencing, and I think recent political events illustrate this in this horrible and dramatic way, that we haven't figured out how to harness this connectivity in a constructive way necessarily, and there are these weird things happening with information getting distorted and information that is not accurate getting propagated, and so in a larger sense that's just something that we have to figure out. And I think there is some parallel with other technologies that in their early days, I've been hearing some stories about, when radio was first around and there was a lot of what we might now call sort of fake news, and how that got somewhat sorted out into, sources of information that people learned were reputable. And, maybe we're in that early days of that connectivity and we have to learn how to handle it. But it is, you want to talk about things that freak me out? Yeah, that is something that we have to figure out. Now, specifically your question about science, I see two sides of this. The connectivity has led to an explosion in people being included in science. There are these citizen science projects where it's amazing. You have these national bird counts on a certain day where everybody dials in their observations and it contributes to this database. And there are all these ways in which the connectivity is facilitating involvement and education. It's amazing the information we have at our fingertips. You can get a free, really high quality education without paying any college tuition, sorry, university administrators here, by going on to Khan University and things like that. There's amazing positive potential. There is some bad science sort of out there, or inaccurate science. Gosh, the talk I gave, I'm going to try to keep this short, but I gave a talk a couple weeks ago in in Boulder. I was on a panel actually at a conference about climate change and solutions. A very positive, packed audience, really good, a lot of good information. But then afterwards, this woman came up to me afterwards and said, you know, you left out the most important aspect of climate change. And I said, what's that? And she said, chemtrails. And I said, well, I'm really sorry, but you know, I and other people who are professional climate and atmospheric scientists don't really think that chemtrails are a real thing. And she said, well, but I know they are. I've been researching it for months. And I said, well, you know, how have you done this research? And she said, on the internet, you know, and then et cetera. The conversation, it didn't really get any better. So, I mean, so this is a problem, and I don't completely have the answer to it, except for I think that maybe it's because I'm a perennial optimist, but I feel as though the power of the, you know, the bright side of the force will defeat the dark side of the force. That information has a way of you know, kind of wanting to spread itself, and that you know, but education is crucial, and we are in some kind of a weird battle for control of those networks. And you know, obviously, if I had a silver bullet and knew how to solve this problem, I'd be giving you a more coherent and concise answer. But I do see tremendous potential there, along with the danger.
Another thing people need to ask themselves, is this right? If it's true, what's the next question? And
yeah, critical thinking.
If you can find something about that on the next question, then it's like, that's probably a good source I have. If the other one is interested in what
we have to teach critical thinking and the ability to recognize good sources of information. Absolutely, yeah. Anyways, I think we probably should shut it down, right?
Let's thank our speakers.